Hello and welcome to Math Time with Dalton. We are going to look at this question here. It's another constrained optimization problem where we have luggage, okay? And basically, without saying it, by talking about the length and the height and the width, we have luggage, which is um, a rectangular prism, pyramid, prism. It's a box, okay? It's a box. Very mathy terms here. It's a box. So, with any type of constrained optimization problem, the steps are always the same. One, we need to find our function and the constraint. We need to solve the constraint for a variable and sub it into our main function. We take the derivative. And then we set the derivative equal to 0, right? And solve for our critical point. We can also use our first derivative test or second derivative test. Typically, here we're always looking at our second derivative test to prove that we found a max or a min. Okay, so in this situation, Sunflight Airlines has a peculiar rule about luggage. It will only accept bags for which the sum of the length, width is at most 39 inches, while the sum of the length, height, and twice the width is at most 78 inches. What are the dimensions of the bag with the largest volume that the airline will accept? So this one is a little bit extra because we are going to have two constraints here. And these could be conflicting constraints. And in real math, there's a whole different way that we might handle this, but like we are doing commerce and math, so it's going to be fine. Okay. So we want to understand here that our goal here is to maximize the volume. They've already given us the variables. Okay. Uh, if we were doing a question like this on an exam, we would always define our variables, right? Let L represent the length in inches. Let W represent the width in inches. And let H represent the height in inches. And again, they already defined those for you. I just want you to be in that mode of like, if this was on an exam, we would do this, okay? And so now we need that main function. So our goal here is to maximize the volume of our luggage. And since it is a box, it is just length times width times height, okay? But then we have constraints. And so you'll sometimes see it written with like the subject to, or you might list off the constraints. And so the constraints here say the sum of which the length and width is at most 39 inches. So we have the fact that the length plus the width has to be less than or equal to 39. And then our second one here is that the sum of the length, height, and twice the width is at most 78 inches. So then we have the constraint that the length plus the height plus twice the width is at most 78 inches. Now, because we're trying to maximize volume, we can assume that we are going to try and take the most out of our dimensions as possible. So even though it would be acceptable for length plus width to be less than 39, we're going to treat these as an equals because we're going to try and take up as much of that volume as possible. Now, with two constraints like this, they could be conflicting where we maximize one and then we can't maximize the other. But again, we're just doing how much math here? It's homework. Okay. So this is not the challenge question you're going to get on your exam like that. So we are going to, our goal here, right, for volume, we currently have three variables, length, width, and height. And at this point in the course, we have not done partial derivatives. So we know that at some point here, we should be able to cancel and sub things in so that we're getting rid of two of these variables so that we can take our derivative with only one variable in there. Okay. So it doesn't really matter which one you decide to do, but we are going to start with the length plus width because there's just two variables in there. Okay. So if I say, hey, I rearrange this, that length is equal to 39 minus that width. Great. And then for our next constraint there, we're going to replace that length with the 39 minus the width. Okay. So we're going to have 39. I can bring that 39 over to the other side. I've got negative W plus 2W. So that's just going to leave me with 1W, right? 2 minus 1 gives me 1. So I have the height plus the width is equal to 78 minus that 39. And I will tell you, lots of people, they stress. They're like, oh my goodness, which variable should I solve for here? It is actually important, okay? Because we solved the L for W. So it didn't matter when I picked L versus W at the first one. But now for the second one, I also want it to be in terms of W. I want to solve for the fact that H is equal to 39 minus W. Okay. This also tells me that L and H are equal to each other. Okay. Your answer will look different if you solved if the whole question in terms of L or in terms of H, and that's okay. But the point here is that for our volume equation, for our volume equation, for our length, we're going to use, 39 minus W. We're going to have W. And for our H, we're going to have 39 minus W. It is a really good idea to simplify before you move on. Okay. So in terms of simplifying here, I'm going to do this in steps. You can just jump right to the end. Great, you're genius. I love it. Go for it. I'm going to multiply that W in. So I'm going to have 39 minus 39W minus W squared. And this whole thing is still times 39 minus W. And so 39 times 39. These are FOIL techniques there. So we're going to have 1521W. Then we're going to have negative 39W squared. Then we're going to have negative W squared times 39. So another minus 39W squared. And then for our last one there, that negative W squared times negative W, which is going to give us positive W cubed. Okay. Just making sure I haven't messed anything up. Negative, negative. Okay. And so 1521W minus 78W squared plus W cubed. Yeah, it actually, I think, would have made a simpler volume equation if you had solved for L instead of W, but that's okay. Yeah, why take the easy way? It's hard to know that right at the beginning. Um, and so sometimes you just roll with it. Okay, so our derivative here is going to be 1,521 because that W um, is there. We're going to have our 78 times 2 because squared term is going to come down. Actually, it'll be negative 156 times W plus 3W squared. Okay. And so this does put us in a situation where we need to solve a quadratic. Um, you could complete the square on this, or you can use your quadratic formula. So if you are going to complete the, or do the sum and product completing the square here, I will say that when we set it equal to 0, you can divide everything by 3 just to simplify a little bit for yourself. Um, I am going to use the quadratic formula here because it's a really good practice, right? Quadratic formula is when we have that quadratic and it's set equal to 0 there. And then our formula is that our variable is going to be negative b plus or minus b squared minus 4ac over 2a. And we're just recognizing based off of our formula that we have here that a is the coefficient of the squared term. So in this situation, 1, b is in front of just the linear term. So in this case, negative 52. And c is that 507. It actually, again, it wouldn't matter if you used these or if you used the 3, the negative 156. And the 1521, you're going to get the same answer there, okay? And so if when we plug in here to solve for W, so in this case it's a W, not an X, but that doesn't change anything really for us, right? We're going to have negative B, so negative 52 plus or minus the square root of that negative 52 squared minus 4. Our A value was 1. That C value was 507. Squishy. All divided by 2 times A. And so in this case, that's just 2 times 1 there. Okay. And so this gives us two different numbers, right? Because you're going to do this once with the plus, once with the minus. So we either get that W is equal to 39 or W is equal to 13. And if we remember that we had that our length was 39 minus W and our height was 39 minus W, if we chose W equal to 39, we are going to get a length of 0 and a height of 0. And this is going to result in a volume of 0, which means if we do a second derivative test, W of 39 is probably going to give us a minimum, okay? And so then if we look at our, okay, what happens when W is 13, right? We're just going to go through and do the exact same calculation there. So for our length, it's going to be that 39 minus W, so minus 13. So our length is 26. Our height, 39 minus 13, So it is also going to be 26. And that means our volume is going to be 13 times 26 times 26, which I cannot do in my head. So our volume here is 8,788. Oh, no, this question was in inches. Inches cubed. Volume is always cubed there. Okay. Now, if we wanted to prove our min or our max, of course, we can use our second derivative test, right? This is our test for concavity. And so we take that original derivative, right? The fact that our volume is 1521 minus 156 plus 3, oh, W plus 3W squared. And when we take, oh, that was the derivative. So when we take the second derivative, we are going to get negative 156 plus 6W. And so if we test our points, right, if we put in, for example, that 39, we're going to have a negative 156 plus 6 times 39. So here we get 78. We actually, again, we don't really care about the value. We care about the fact that this was a positive number, right? Smiley face. Therefore, we have a minimum, right? So when the second derivative is positive, it means that we're concave up. We have a minimum at W equals 39, height equals 0, length equals 0, which makes sense because the volume literally worked out to be 0 in that case. If we test our other point of 13, we're going to have that negative 156 plus 6 times 13. Get negative 78. It doesn't mean anything that they're the same number. Don't worry about that. Again, we just care about the fact that it's negative. Okay, that's funny first. And so that means it's concave down and we have a maximum. So that second derivative is negative. So then we have a max at that W equals 13, the length equaling 26, the height equaling 26. Okay. Now, I will say we only ended up having to solve with the quadratic because of how I chose to rearrange these equations here. Okay. If you had done this with your volume of length, width, height, and we had those two constraints, length plus W is equal to 39, length plus height plus 2W equals 78, okay? If I had solved for length instead, and there's really not a way to know this beforehand. So if I had width is equal to 39 minus the length, and I put this in here, so I'm going to have length plus height plus, and instead of W, I'm going to have 2 times 39 minus that length. And I'm going to simplify this. Then I'm going to end up with length minus 2 length. That 78 coming over to the other side. So literally just length, height minus length is equal to 0. So height equals length. And then these are our two that we plug in. And so when we do our volume function in this situation, right, our length stays our length. That's fine. The width is 39 minus the length, and the height becomes the length. And you can see that this is actually it's actually the same as what we ended up here with width, but you don't end up with the same quadratic situation there. So we end up with the volume, right? If we just multiply this one in first, we're going to have 39L minus L squared all times L. And then we're going to end up with 39L squared minus L cubed. And so when we take the derivative here, okay, well, we're going to end up with 78L minus 3L squared. This is still really important, right? We set it equal to 0. Just want to show you one thing. So in this one, we still have a quadratic, but we don't have to solve with quadratic formula because we can actually just factor out one of those L's. And when we have things related by multiplication like this, and we've set it equal to 0, that right-hand side is going to equal 0 when either the L equals 0, which is what we figured out here, which happens when W is equal to 39, or when 78 minus 3L equals 0. Either one of those can be true, and the whole thing's going to be 0. And so in this situation, we get 78 is equal to 3L. So L is equal to 78 divided by 3, aka L is going to be equal to, hopefully, I'm just going to double check that it gives us the same answer. Yep, 26. Okay. And so in that same vein, right now we have two potentials. We either have L is equal to 0 or we have L is equal to 26. We know that H is equal to L, so this would tell us that this point H is just equal to 0 as well. And we know that W is equal to 39 minus L, so this gives us the fact that W is equal to 39, and this would give us a volume of 0, right? So we get the same set of points as we did above. Here for L equal to 26, again, height is equal to length, so that height also equal to 26, and W was equal to 39 minus that length, and so we're going to get 13 there. And again, exact same answer as we got above. You'll get to the same final place. If you were doing this on an exam or something, it really doesn't matter which one you solve for. I just wanted you to recognize it. It kind of does suck when we end up in a situation where it's like, ooh, that's a little bit of a mess here because we have to remember our quadratic formula. But truthfully, if I was on an exam, you can't be 100% confident that if you went and rearranged it for another variable that you wouldn't end up into this exact same quadratic situation. So knowing this quadratic formula is essential for your exam. Okay.